Assalamualaikum warahmatullahi wabarakatuh. Today, Group 5, Section 1 will present about friction. First of all, let me introduce my group member. Number 1 is Muhammad Adasufi bin Muhammad Safri. Number 2 is Muhammad Aiman bin Lakaman. Number 3 is Muhammad Adi Akmal. And last one is Muhammad Harisinil bin Muhammad Ikmal. For introduction, first of all, what is friction? Friction is the force exerted by two surface sliding or attempting to slide across one another. For example, when you try to push a book across the floor, friction makes it harder. Next, friction has many benefits for our life. For example, it keeps our shoes from slipping on the pavement and car tires from skidding on the road. Last, for introduction is, did you know that we can use oil to minimize friction between moving elements?
Okay, hello, my name is Alam Sufi and I will talk about background of case study. There are 4 types of friction, which is static friction, sliding friction, rolling friction and free friction. So number 1 is static friction. Static friction, it acts on objects when they are resting on a surface. For example, if you are hiking in the woods, there is static friction between your shoes and the trail each time you put down your foot. Without this static friction, your feet will slip out from under you, making it difficult to walk. In fact, that's exactly what happens if you try to walk on ice. That's because ice is very slippery and offers very little friction. So number 2 is sliding friction. Sliding friction, it is the friction that acts on objects when they are sliding over a surface. Sliding friction is weaker than static friction. That's why it is easier to slide a piece of furniture over the floor after you start it moving than it is to get it moving in the first place. For example, there is sliding friction between the brake pads and bike rims each time you use your bike's brakes. This friction slows the rolling wheels so you can stop. Okay, number 3 is rolling friction. Rolling friction, it is the friction that acts on objects when they are rolling over a surface. It is much weaker than sliding friction or static friction. This explains why most forms of ground transportation use wheels, including bicycles, cars, 4-wheelers, roller skates, scooter, and skateboards. For example, the ball bearings in this wheel reduce friction between the inner and outer cylinders when they turn. Number 4 is fluid friction. Fluid friction is friction that acts on objects that are moving through a fluid. A fluid is a substance that can flow and take the shape of its container. Fluids include liquids and gases. If you ever tried to push your hand through the water in a tub or pool, then you have experienced fluid friction. Another example could be a swimmer cutting through the edges of water where the water provides fluid resistance to the swimmer.
For basic theory, when one body tries to slide over another, an opposing force known as friction is created as a reaction to the applied force and act in the opposite direction. You know that when the applied force F is increased beyond the limited frictional force, the body begins to move, and the force opposing the motion is known as kinetic or sliding friction. There are also some laws of static friction, like first, the magnitude of limiting friction depends upon the nature and state of polish of the two surfaces in contact. Second, the magnitude of limiting friction is independent of area and shape of surface in contact as long as the normal reaction remains the same. And the last one is the magnitude of limiting friction F is directly proportional to normal reaction R between the two surfaces in contact.
Now I will talk about analysis and calculation. Based on figure 1.1, Ayman's car was out of fuel and he needed to push his car, which weighed 500 Newton, to the nearest oil station by himself. While on figure 1.2, Lily and her husband's car also out of fuel and needed to push the car, which weighed also 500 Newton, to the nearest oil station. Which of the following diagram depicts the greater amount of force used to push the car? Friction on the road has a coefficient of friction of 0.7. Please provide an explanation for your response. So the solution for figure 1.1, when y-axis equal to 0, R minus W equal to 0. R is 10 for magnitude of the object and W is 10 for weight of the object. R equal to object and that's mean R equal to 500 Newton. Now find the friction. F equal to friction and micro equal to coefficient of friction and R equal to magnitude of the object. So then F equal to 0.7 multiplied by 500 and the answer of the friction will be 350. And last one is when x-axis equal to 0, P minus F equal to 0 and P will equal to for the force that applied to the object and F equal to friction. And then P equal to F and that's the answer for force to the object will be 350. Now the solution for figure 1.2. When y-axis equal to 0, R minus W equal to 0 and that means R equal to 500 Newton. So that the friction for the car is when F equal to 0.7 and multiply by 500, the friction will be 350. So when x-axis equal to 0, P minus F and equal to 0, that means P equal to F. So the force that applied to the car is 350. When the car is pushed by 2 people, that means 350 will divide by 2, that means the answer will be 175. Thank you.
I will continue with discussion. Firstly, rolling friction is the initial type of friction. When the car is being pushed, the tire pushes the road backward, and when the car is traveling in a straight line, the road pulls the car forward. The friction between the tire and road propels the car forward. When an automobile is pushed, this is known as rolling friction. Static friction is the second type of friction. Static friction occurs when two objects touch or push against each other without sliding. Your car moves forward due to static friction. The friction between the wheels and the ground is static friction when the car moves without slipping. This is force that propels an object forward. As a result, it travels in the same direction as the car. The fluid friction is the last type of friction. A fluid is defined as something that does not have a particular shape, such as a gas or a liquid. Fluid friction affects both gas and honey, for example. Fluid friction is resistance that happens when something tries to move through or on a gas or liquid. Fluid friction happens in this situation when the car is pushed forward and there is air present, which causes fluid friction because air is a gas. As a result, while moving the car, air creates some friction. As a result of the friction, the car becomes easier or harder to push in this situation.
As an example of a conclusion, when two surfaces move relative to each other, friction converts kinetic energy to thermal energy, that is, it converts work to heat. The use of friction caused by rubbing pieces of wood together to start a fire is an example of how this attribute can have serious consequences. When motion with friction occurs, such as when a viscous fluid is churned, kinetic energy is converted to thermal energy, where is another important side effect of various types of friction, which can lead to performance degradations or component damage. The science of tribology includes friction as a component. Friction is both desirable and necessary for traction and movement on land. Most ground vehicles rely on friction for acceleration, deceleration, and direction change. A sudden loss of traction can result in a loss of control and an accident. Friction isn't a fundamental force in and of itself. Drive friction is caused by intersurface adhesion, surface roughness, surface deformation, and surface pollution. Because of the complexities of these interactions, calculating friction from first principle is impossible, necessitating the use of empirical methods for analysis and theory development. development. Because friction is a non-conservative factor, work done again it is path dependent. When there is friction, some energy is always lost in the form of heat. As a result, there is no mechanical energy preserved.